Hi, techies. On this episode, I will be discussing with Godsin on how you can secure your mobile applications the proper way and how you can make sure that your user data are safe. Hi, Godsin.
Hi,
How are you?
I'm good. How you doing?
I'm fine. It's good to have you here.
Yeah, same.
So tell
Pleasure.
me, how does it feel being a tech lead in the financial sector?
Oh well, I mean, it feels great because you get to like work with a lot of great minds. You get to lead people and then you get to mentor them as well.
Okay.
So, but it can be really tricky with having guys because when you lead, you're probably the most experienced guy
Mm-hmm.
on the team. So you definitely have people make costly mistakes, on your team,
Mm-hmm.
and then you're going to be accountable for those mistakes. So when you work in finance, you need to be very, very cautious because you can't tell the extent to which those mistakes could, get. It could be very, very costly. It could lead to, loss of high volume of funds.
Yeah.
It could lead to data integrity, leak of data, basically. So yeah.
So yeah, just like I said, considering the performance of mobile applications in the financial sector, how would you say you've really like helped your team to build a good application?
Okay, so for me, I'm really high on security.
Okay.
So yeah, when it comes to talking about security, I love it.
Okay.
So I believe when building mobile applications, you need to put in the best of securities. So
Okay.
personally for me, when I build, I sort of build like a hacker. I build like somebody who is trying to break, right?
Yeah.
So I can understand what's what a malicious person would be trying to do on the application I'm building.
Mm-hmm.
So I try to cover as much loopholes as possible. So definitely you might have one or two loopholes you might not find.
Okay.
But for me, when I work on mobile applications, I try to put in the best when it comes to security. When it comes to storing data on the device, I make sure those data are actually encrypted. So, but I guess we'll go into full details later in the session.
Definitely. So when you talk about fortifying mobile applications,
Yeah.
what does it mean in practical terms?
So, fortifying mobile applications just mean being able to build secured mobile applications, right?
Okay.
You build an application that cannot be penetrated, that cannot be reverse engineered, or cannot be intercepted in terms of the HTTPS request
Okay.
that comes out of your application. So basically, fortifying your mobile application is just ensuring that your application is solid enough to go to the market, because in a society like Nigeria, once you have a fintech, you have so many people trying to like hack your fintech.
Mm-hmm.
A lot of people don't know this, but the moment you build a fintech, you would get a lot of users, trust me. So KYC is also one of those things you need to also ensure you have the moment you're rolling out a fintech,
Okay.
because you need to be able to know the users that come into your application. So
KYC, know your customer.
yes.
So when you want to try to like work on your KYC, are you talking about just the document now, or you have to really know the customer in person?
So you don't need to know them in person. I mean, so
Okay.
when you have their documents, you've gotten to a good extent, then liveliness comes in play. Being able to verify the liveliness images of those customers, right?
Definitely.
And then you can actually match it against whatever data you have of them, maybe their NIN, and then match it against their first name, middle name, and last name. So yeah, that's the whole KYC process, basically.
All right. So talking about securing our mobile applications, have you witnessed any breach, your personal experience before?
Yeah.
Okay.
So
Can you tell us about it?
yeah, I've witnessed a couple, but I think the one I'll talk about would be one I was part of.
Okay.
So yeah, I was working on a product with someone, and then we had a use case where we needed to access the bank logos. So when you use your mobile apps for banking, you tend to see the bank logos. So we needed that data, and we didn't have it.
Okay.
And then we sort of saw that one of the banking apps, a top banking app, had it. And then
they have the logo.
They had the logo, and we needed it.
Okay.
So we put a reverse engineering on the app. So I'm not going to call the bank's name. So yeah, we were able to actually reverse engineer the application.
Okay.
We extracted the APK file from the Android device. Then we renamed the zip, and we got the classes.dex file. And then we were able to track where they actually hosted it. So it was hosted on Firebase.
Oh.
They hosted that whole data on Firebase, and
wow.
Because their app was not well protected, that's why we're able to actually reverse engineer the application. So I mean, if you're building a fintech out here, you really need to be very, very careful, because it's actually very, very big known fintech. Yeah.
So you mentioned Firebase. Do you think Firebase is secure in, should I say deploying now, or building like deploying our applications compared to other cloud platforms?
So I think Firebase is secured. I mean, Firebase is actually secured, but I feel there's a limit to
Okay.
the kind of usage you should use Firebase for,
Okay.
right? So I don't expect you to be storing or hosting all of your data on Firebase. I think Firebase should come in when you need to do stuff like cloud messaging,
Okay.
stuff like that. But it shouldn't be like a dependent back end for you, right? But in
Okay.
terms of hosting, I give it to Firebase, yeah.
All right. That's good. So when you talk about authentication, because it's very important in mobile applications, and section management, how do you go about it?
So when it comes to authentication, you know, authentication is just a way to verify that a user is who they say they are, right?
Mm-hmm.
You want to verify their email
Mm-hmm.
and their password as well.
Mm-hmm.
So one thing we do is we use the JWT, the JSON Web Tokens, right?
Okay.
It's actually very secured because you can get 3 encoded base 64 URLs that are separated with a full stop, right?
Mm-hmm.
So when you have that, you have the head, you have the signature, and then the middle is the payload. So you take that, you split the base 64, right? You divide it by everywhere you have your full stop. So you take the payload, you decode the payload, and then under that decoded payload, you have all of the data you need, the access token, refresh token, and maybe the first name and last name.
Mm-hmm.
So one thing you need to make sure is that you have a very, very realistic timeline for expiration. So when you're dealing with JWT, you need to make sure you expire them, within a timeline. And then you also need to make sure you make provision for a refresh token. So once that token expires, the users can actually refresh on the application. So that's basically how we handle basic auths.
Okay, so talking about refresh token, although I know how it works, but I'm just considering the fact that we're trying to secure our mobile apps. When their section expire or their token expires, do you think they should be able to refresh or just log them out?
Well, there are two sides to that, right? We have the section management that happens on the app for the inactivity that logs you out and says, oh, you've not been active on the app, right? And then we have the token expiration that happens directly from the back end. So now, because of the user experience, a user might be trying to do something. You don't just want to take them out of the app just because their token has expired. So we have interceptors that are actually put in place to handle those processes. So it happens as seamless as possible. The user would not even notice anything happen, right? So you're trying to make a request, and then the backend says, oh, this token has expired. You're probably unauthorized, right? The interceptor picks it up, sends the refresh token, generates a new access token for you, and then you just proceed with your request. So yeah.
Okay. I'm going to ask this. So aside Flutter, do you know about other
Yeah.
Can you build other apps like what's it called now?
Kotlin,
Kotlin, Swift, React Native.
Yes, so I do React Native.
Okay.
React Native is actually what I started with.
Oh, okay.
Yeah, before I left for Flutter, yeah. So I do a bit of Kotlin, a bit of Swift as well.
Okay. Unrelated, or should I say unrelated or is related? So if you have to compare Flutter and React Native, how secure is which one would you?
React Native community will come for me.
Really?
Yeah,
well,
so
okay.
I feel Flutter is more secured. Yeah, I feel Flutter is more secured.
Okay.
I've spent more years writing Flutter than React Native. In my early days, I wrote React Native, but currently I've spent more years writing Flutter, so I'll definitely say Flutter is more secured. But so the good thing is most of the security things you can put in place in Flutter is also similar with React Native. So, the likes of the SSL pinning and all of that, you can do it on both Flutter, React Native, Kotlin, Swift, whatever platform it is. Yeah.
Okay. So how can developers manage data transmission on the application without a breach or something?
Okay, so encryption, that's it.
Okay.
So encryption is very, very necessary, right? When you're transporting data from the client side to the server. So we have the AES encryption, we have RSC. So we have a couple of encryption standards and algorithms. So basically, you want to ensure that when you're dealing with sensitive data payloads, you encrypt that payload and you send it to the server for decryption, right? So, in situations where the whole payload is not sensitive, let's say it's a username and a password, you might not see a need to encrypt the username. So you can encrypt just the password and send it to the server. But there are situations where you're sending transaction PIN and a couple of other, sensitive data, and then you just have to encrypt the whole JSON payload.
Okay.
So encryption is one way to make sure you transport data securely. Another way would be SSL pinning.
Okay.
I know we might come back to that later, but
Alright.
SSL pinning is also very important, right? Because it creates a trust
Okay.
from the client side to the server side, thereby eliminating every form of a middle in the man in the middle attack, rather. Yeah.
All right. So, do you think Cores works for mobile app?
Cause
Mm.
when you
Cores
talk,
Origin. Of course, it works on websites, but
yeah,
for mobile apps, I don't know if it works. I'm not sure.
I don't know much about that.
Oh, okay.
No,
All right, that's fine. Okay, so can you just show us the best practices that developers can actually carry out when building their mobile applications in order to secure their user data? You
yeah.
can just tell us few practices and just show us how it works.
Okay, definitely. So I think first off, I'll talk about SSL pinning.
Mm-hmm.
So let me just break that down a bit.
Okay.
So when it comes to SSL pinning, it's like I said earlier,
Mm-hmm.
is a way of creating trust from the client side to the server side, right?
Mm-hmm.
In terms of communication. So when the certificate does not match what you have server side or client side,
Mm-hmm.
right? There is no handshake. So we have two types majorly, which is the certificate pinning, and
Okay.
then we have the public key pinning. So for the public key pinning, you hard code the public key on your app, actually, either the public key or the hash. So it's
On your
advisable.
app, like
Yeah,
the client side or now
the
the
client
server
side.
side?
No,
Okay.
so it's already resides on the server side.
Mm-hmm.
So you just need it on the client side to be able to validate that whatever communication you're trying to establish is actually coming from your own server, right?
Okay.
So let's just look at something.
All right.
Okay. Okay, so for the SSL pinning, I already have this code here that I just it's boilerplate. So I'm going to show us how this works basically, right?
Okay.
I have created a get SSL here, right here.
All right.
So what this does is, what we're going to be doing is certificate pinning. I told you there's the public key pinning, right?
Mm-hmm.
That uses the public key hash. So what we're doing here is certificate pinning. It's easier, right, and faster for us because
Okay.
of the session. So I'm going to be downloading two certificates.
Okay.
One is going to be the certificate for google.com and one will be for news API. So I'm going to show you everything here.
All right.
So basically this function we have here just, is going to read the certificates. It's going to get the SSL, right? Then this is going to read the certificates locally for us. So let me just go straight to that. Okay. Put this here. Okay. Okay, so here we're on google.com and I'm going to show us how we can just get the certificates from here. See, the certificate is valid. So go to details and then we export this.
Okay.
So I'm going to save this in my downloads. And then we have this here. It's a .pem file, by the way.
.pem?
Pem, P-M.
Pem.
Yeah.
Oh, okay.
So I'll just say this is Google. Right. And then I'm going to get a second one. And the second one comes from this news API because we'll be hitting an API with two different certificates. One would be the trusted certificates. The other would be the Google certificate.
Okay.
So I'm going to also download the news API certificates. So you can come here and then you click here. So by the way, if it's a valid certificate, you see it by the side here. It says certificate is valid. So just a second. Okay, so I'll just paste the other certificate here.
Okay.
So I just call it, let me just call it certificate since it's going to be the main one we'll be using.
Okay.
Make sure I got that spelling. Okay, so what we'd want to do here, so for every Flutter developer, I believe we all know this is how we can read files, maybe a .json or a .pem file.
Okay.
So I already have my assets in my popspec.yaml file.
Okay.
I already added my assets here. So this is it.
Okay.
So we can go straight to this place and say the file we want to read is at assets slash google
Okay.
dot pem. So we're going to start with the Google certificates, and then I'm going to open the service because I already have a service file here.
All right.
Now the service file hits the news api.org. So if you understand certificate spinning, what this means is that we're trying to read a certificate on the app, which is the google.pem, but that certificate does not match the news API certificate. So obviously, if we try to send a request now, it's actually going to fail, right?
Yeah.
So I'll do that now. Let me get this rolling. Okay, so here we have the service file. Like I said earlier, the service file reads the service file is going to be calling the newsapi.org. And currently what we have configured here is the Google certificate, right? So what we'll be expecting would be a handshake error because it's so the trusted C for the news API org does not accept the one we've pinned on the application currently, which is the google.com. So I'll click play here. And yeah, so we have that. So if you look at the terminal here, you'd see we have the handshake exception.
Okay.
Now, this is because we've configured a different certificate on this application. So how this works in real life is I have my APIs and I have my base URL. We have our domain. My backend guy can provide me with the certificates. And I know you'd want to ask that if anybody can access the certificate, how secure is it? Because I mean, I downloaded the certificates just from a site. But so if you have the certificate, it doesn't mean you can do anything, right? Because every server has a private key and a public key. So even if you have the certificates, as long as you don't have access to the private key, you actually can't do anything. So the certificate is just a way of pinning the mobile app to know that, oh, whatever request you're sending, you need to verify that before the server accepts it, this server contains this particular signing, and then anything coming into the mobile application, you also confirm that it comes from the server with this same certificate signing. I don't know if you understand.
I get that.
So, like I said, what this prevents is a man-in-the-middle attack. So, without SSL pinning, somebody can actually intercept a request and reroute it, encrypt, decrypt, do whatever they want to do if you don't have SSL pinning. So now we've seen the situation where we used a different certificate. Okay, so after the results we saw the previous time when we were using the wrong certificates, we've now updated certificates to use the certificate.pem, which is the valid certificate for the API we're trying to hit. So it's currently building. We'll see what the result looks like. So we'll be hitting the news API service now with the certificate for the news API.
All right.
So let's just hold on. So here we have the results. We have the list of data here. So it wasn't working the other time because we were using a wrong certificate, but now we have the valid certificates configured for this. So this is the same way it works in real life, in a real fintech application, right? When you have your SSL pinning, you're able to validate that this the server certificate matches the device certificate you have with you, right? So that way nobody can come in the middle of your request and then intercept it because it would only listen to that particular certificate. So, but one thing to note is when you're doing certificate pinning, if your certificate gets updated, you need to actually update your application. You need to create a new build. So most times it's recommended to do public key hashing because that's more flexible. So even if you generate new certificates, you still have your key value pairs as long as those are not regenerated. So yeah, you can update your certificates as you want, but still have the same implementation on your application without having to create new builds. So this is actually very, very, when it comes to SSL pinning, is my go-to because it's very, very essential in eliminating a man-in-the-middle attack.
All right. So you talked about when the SSL certificate change.
Yeah.
So why do we need to change that?
So it might expire. You might need to update it. There might be certain reasons, basically, why it might actually expire. So yeah. But once it's changed, you don't need to change your pins, your value pairs. Yeah.
Okay. Is it the public key or
public key? So the public key is what you have on your own end, the public key hash. The private key would always reside in the server because you know the way this thing works, it works like an encryption as well. So the private key is the only thing you can use to actually decrypt whatever request is coming to the server. Yeah.
That's nice. Okay, so can we test for the Google PEM, or it's of course it's going to work the same way?
Yes, it works the same way basically.
Okay,
You want
so
us to run a test or what?
I don't know. If you don't want to run a test, you can just show us other ways where we can secure.
Okay. So
Yeah.
other ways we can secure the application. Let's see. Let's talk about JWT. I think I've spoken about
Yeah,
JWT.
you talked about
But
it.
yeah, this is a simple JWT implementation. Yeah. This is a simple JWT implementation. I have my JWT here.
Okay.
Right? It's encoded. So this is what I get from the back end when I try to log in.
Okay.
Right? And then I split it, like I said. So let's just run a quick test with this on the home screen. Let's see.
Okay.
Just change it to click me. Yeah. Hold on. Just say print. Okay, I already have data there. Just say print decoded. Right. Just change the home. So profile page. Okay. So let's give this one a try.
All right.
So we have a button that says click me, login.
Okay.
So yeah, when you click this, can you see the data we have? Yeah. So all of this data basically came from what we had encoded in our JWT.
Yeah.
So I think, a lot of companies don't really use JWT. They just use direct access token as part of the response, which I don't think is the best, honestly, because if somebody's trying to exploit a vulnerability, you're already directly giving the person the access token. At least, even if the person would get access to it, make it harder.
Okay.
Yeah, I mean, the person should go through the stress of having to decode first. So yeah.
So if they don't use JWT, then what other thing do you think they will use?
They just directly put the access token in the payload. So instead of giving you a JWT for you to decode, some guys will just give you as a direct response and say, this is your access token, this is your data, this is yeah.
Okay, yeah.
You understand what I'm saying? So yeah, that's pretty much it. Okay, I think something else I want to talk about would be when it comes to storage. Storage on the mobile device. All right. So I'm talking to all Flutter developers. Please stop using shared preference. Please stop using shared preference to store users' data. Yeah. So it's a common practice for a lot of engineers to use shared preference. So why shared preference is not good is because it's not encrypted. Yeah, it's not encrypted. So, and you see people using shared preference to store username and password. So if somebody roots your device or somebody steals your device, they can easily decode that data from your device. So my recommendation is to use Flutter Secure Storage. Flutter Secure Storage uses a native way to store data. So on Android, it uses what is called the key store. On iOS, it uses the keychain, and all of these have encryption mechanism implemented in them already. So when you use Flutter storage, secure storage, whatever username and password or PIN or whatever you're storing on the device is automatically encrypted. Right? Yeah. So that is way better than using shared preference. Okay. So actually I have a question. So when you were explaining about encryption the other time, you talk about encrypting our payload. Yeah. So I just want to be sure if the encryption is coming from the client side or it's coming from the server side. Okay, great question. So yeah, it depends on the type of encryption you're doing, right? So let's say you want to implement a full end-to-end encryption, right? We have the key pairs, which is the public key, and we have the private key. So we have the AES encryption mechanism, and we have RSA. So AES is the standard encryption standard. If you're using the AES, all you need is one key. The AES works with just one key, and that's like the secret key. That key is used for both encryption and decryption. So client side, you encrypt with that key. Server side, you decrypt with that key. But if you're using like RSA, right? You need two key pairs, which is the public and the private key.
Okay.
Now, the public key is always used for encryption. The private key is going to be used for decryption. So on my end, I have my key pairs. On the back end, you have your own key pairs. And then you need to also ensure that those key pairs are stored securely, especially the private key, because that's what you'd use to decrypt. So if me as a client, I'm sending, I want to send a payload to the server, I encrypt with my public key, send it to the server decrypts with the private key. Now the server wants to send me a response back in an encrypted format. The server encrypts with their own public key, sends it to me, then I use my private key to decrypt. So that's basically the flow.
All right.
So, but one thing is, these keys are just one key pair for every single user on the application. So that leads me to the Diffie-Hellman's. Yeah, is it Diffie-Hellman? Yeah. There's this, hold on, let me check. I think I have, yeah. Just a second.
All right.
This is one of the best encryption algorithm for me.
Okay.
Yeah, I was right, Diffie-Hellman.
Okay.
So how the Diffie-Hellman encryption standard works is it generates a key pair for you and I. Okay. And then those key pairs, we're not using them to encrypt. We're going to generate new key pairs with those key pairs. Okay. So I'm using my own key pair to generate a secret key. You use your own key pair to generate another secret key. So now when I'm sending any sort of request to you, so I can do it in a way that those key pairs are generated for each user that comes on the application. Hope I'm not confusing you. No. Because the previous standards I spoke about, they use one key for every single user. So if you're using the Diffie-Hellman, you can make it in a way that every single user that comes on board on your application has their own secret key. So even if tomorrow somebody is able to have access to a secret key from your application, only one user gets affected and not your whole users. Yeah, I get that. So it's like one of the best algorithms for me. Okay, so this Diffie-Hellman, is it like an SDK or no? It's just a standard. I have an implementation somewhere, but it's sort of a bank's implementation, so I can't. Oh yeah, I get you. I get that. How it's used, yeah. But basically, so the way you use it is a key is going to be shared to the server. Okay. That key being shared to the server, even if somebody intercepts that key, you can't use it for anything. The server will use that key and a private key to generate a secret key. The server is also going to share me another key. One? Yeah, that key, even if it gets intercepted, nothing can be done with it. Okay. I'll use that key with my own private key to generate another secret key. So the secret key I generate is what I'm going to be using for encryption and decryption. Same with the server side. Okay, so when you say the server side, are you talking about the backend APIs now? Yes, the backend, yes. Okay, so generally, when you mention the server, you're talking about the backend? The backend, yeah. Oh, okay, yeah. All right. Server side, okay, yeah. Thank you. Well, is that all you want to talk about when you talk about fortifying mobile applications? Is that, I know it's wide. I know you can't talk about all the security, but the major ones, do you think you've touched everything? No, so definitely not. So device token, so it's called device auth. Okay. Very, very important. Right. Not a lot of fintechs use it. Okay. Some use it, but not a lot of fintechs. It's very, very important because it's a way of tying a device to an account. Okay. So you don't want a situation where users can log in their accounts on multiple devices. So imagine I'm able to log in my bank app on this device. My friend is able to still log in my account on his own device. I mean, you know the kind of fraud that could actually go down that way, right? So it's essential to tie users' accounts to one device. So when a user comes on registration, you pick the user's IMEI number, right? Or serial number, whatever it is, and it's unique. It's unique to devices. Definitely. So no two devices can have the same IMEI number. So you tie the accounts to it. So on every login request, you verify that the device ID being sent to the backend matches what was stored for the user on sign up, right? Then you could also provide users the option of unlinking their devices, right? So in a situation where my phone gets stolen, right, and I need to log in my account, right, I should be able to still log in on a new device, right? So that's where KYC might come in and liveliness, right? So you can now do a liveliness check of my face to validate that, oh, I'm the owner of this account before letting me sign up or log in a new device. So there's also another situation. So for companies that like give out loan, so I mean, I kind of worked with a fintech and somebody was able to take loan with two different accounts on the same device. Wow. Now that's crazy because in the first place, he's not even supposed to be able to log in another account on that device. And okay, even if he's able to, I mean, when you're running loans, a user should not be able to have running loans on the same device ID. So I think device ID is very, very essential when it comes to building fintech, because you don't want people messing around with your application and all of that. Yeah.
So like that, I'm so curious about that. Is it that the person used another email or
I
same
mean,
email?
I didn't have the full context. No,
Okay.
it was a different account on the same
On
device.
the same device. So it means
So
they have two apps.
yes, no. So the person logged out and logged in.
Login.
So that's why it's essential to tie device ID to an account. And even if the person was still able to log in, the fact that and the funny thing was, there was the infrastructure there to actually see that this guy has two accounts with the same device ID. So he was able to use the same device ID to take 2 running loans.
Wow.
2 running loans, yeah.
I think this is very important too. So you don't want to tell us this one before. This is it's critical.
Very, very important. Yeah.
Yeah. So now I can relate to when I want to use maybe I download, like maybe I stop using a phone, I change my device, and I want to log into my app, and it tells me you've been logged in somewhere or link, and that's where it comes in. Yeah, that's very important. Yeah, thank you so much. So which other important info do you think we need to know as developers or mobile app developer?
Okay, I don't think people should be able to run your production application on simulators, Flutter developers.
Simulators, what do you mean by that?
So, I mean, we build on simulators. That's when we test applications. It's just this
that's
virtual.
okay.
So people should not be able to run your production application there. You need to make sure you have a check, or you either use Flutter flavors. You know, flavors meaning you have environments, your staging environments, your develop and your production, whatever you have in your company, right? So people should not be able to run your production accounts on simulators, because simulators are not really coupled. Like, how do I explain this? Simulators are loosed. They are not real physical devices. So there are things people can actually do on simulators to, you know, exploit your application, right? And it will go without a trace. Yeah. So people should not be able to run your production accounts on simulators. Then also rooted devices and jailbroken devices. You need to, so there are packages you can use to ensure that a device is not rooted. Because when a device is rooted, they can exploit and reverse engineer your application. Because this person is running from a rooted device that has been jailbroken, and then they have access to other things that normal device users would actually.
Jailbroken, don't pass me on. Explain better.
So rooted devices. So have you ever seen people who have iPhones that can run on Android OS? Something like that.
Really?
You see like an iPhone, but when you look at it, you can see Android.
What's now before?
That's like an example. There are people that have that. Yeah. Same with Android phones. There are Android phones that are actually rooted.
I think I've seen the Android and
you've seen
iPhone.
Stuff like that. So those are actually rooted devices. They are prone to vulnerabilities. Basically, they have access that they shouldn't actually have. And then you don't want your application, a fintech application, you don't want it running on a rooted device, because you can't tell the extent the user can go. Because in the first place, why do you have a rooted device? So pretty much, yeah.
I guess that would be all.
Yeah, for rooted devices.
Now.
Yeah.
So for the developers out there, I feel like, is that all for them to know?
Well, I think so. I mean, at the same time, I would want to talk a bit about form validations. You know, this is now moving towards validations, right? When you're dealing with forms, you need to make sure your forms are well validated, because you don't want somebody coming to just do a cross-site scripting on your app, just put in some weird characters, and then before you know, the person is injecting your database or something. So it's also very, very important. And then, so we once had one of my friends actually in his company, he had an experience where they were still building, the app was still in the building phase, and then somebody did something very crazy. So the backend guy, because they were still building, he used a minus in front of amounts from his code, and somebody used the test mobile app and put a minus in the text field. I was able to send money, because minus times minus is plus. So the person did that, and they were able to find out when they checked what happened. It was from the beta app they had for test that somebody actually sent that request from, and the person actually put a minus. I guess the person was just probably playing around, or the person had already seen the back end and had already seen the implementation there. So this is why it's very, very essential to have validations. And this is also one reason why your application should not run on simulators, because you might have a text field that you say, oh, this text field should be just numbers. And then somebody might be able to manipulate that on a simulator and still be able to put like a leading minus in front. And then, you
Of
can't tell
course,
the
the
extent
system
of
will just
damage.
calculate it.
Exactly. So,
Well, thank you for putting us through all this. Of course, I would say that I'm not a mobile developer, but I learned a lot, because as a backend person, I still need to learn how I'm supposed to secure my codes and my application, and how it's going to work in the client side.
Yeah.
So if our audience wants to reach out to you, of course, because you've not told us everything, I'm sure there are more. And considering the fact that you work with one of the biggest financial sector, so I'm sure they want to also ask some other things, some other implementations. Probably you have some codes in your GitHub you want to share and all of that. So how can they reach out to you? On your LinkedIn? Are you on Twitter?
Yeah, so I'm not really a Twitter person.
Why?
Yeah, I
A
don't
tech
know.
bro. Why?
I have a boring lifestyle, so
Boring lifestyle.
yeah.
You don't look like one.
Well,
Oh, okay. So
I mean,
LinkedIn.
to an extent, yeah, I use LinkedIn. Yeah.
Okay.
So that'll be Godson OKZA on LinkedIn. That'll be
Okay.
GODSON. Then my surname OKEZIE.
Right.
So it's Godson OKZA on LinkedIn. So I use Instagram. So
well, I know that you'll be on premium. People cannot even chat you on LinkedIn.
no, not anymore. It has expired. No money to renew.
They lie, you have money. So unrelated, as a tech bro,
Yeah.
of course you have your hair done. So why do you have piercing?
I used to have.
So why do you remove it? Bank?
No, not bank. So funny story. I was doing my NYSC. It was 2021. I served in Oyo State.
Okay.
So my platoon inspector, I used to wear my earrings then. So he saw me one day and I was like, he came to me, I was like, oh, that this my earrings that I wear. That it makes me look irresponsible. But that when people get to talk to me, you get to realize that I'm actually a responsible person. But that what people see is the looks and not the what's it called?
Your person.
Yeah, not the personality. They just see the looks. So after that day, I just jokingly told him I was going to remove it. I removed it and then I never wore it. I don't know why. For some weird reasons, I never wore it. But yeah.
But you look good, by the way.
Thank you.
And thank you for coming. I hope you would show up again when we call you.
Definitely. I mean, when we had the previous conversation, the calls, I don't know if you're on that call.
No.
Okay, I had a couple of topics I wanted to share before I chose this one. So, I mean, I feel like there's still more in the box to share with you guys.
I will. All right. Yeah, we'll be glad to have you.
Definitely.
Thank you. All right. I believe we've learned one or two things as a developer, not just a mobile developer, but as a backend person also. I'm sure you pick one or two things from what Godson showed us and also explained. Also, don't forget to follow us on our socials. We're on LinkedIn, Twitter, Instagram. We also have a community where you can join and meet someone like Godson there. I mean, someone like me, of course. I mean, 7 small. So, and also developer, CTO, HRs, get job links and all of that. So follow us and get more insightful topics and, of course, insights like this. So until we meet again, bye. I remain your girl, Chazzy.